So welcome to the session. Today's session we will see how we can solve a set of equations using Gaussian elimination method. This is a equation that's been given. So first step what you have to do is step 1, you come up with a augmentation matrix. So first you write a augmented matrix. So what is a augmented matrix? Augmented matrix will have two things. It will have coefficients of the matrix and it will have the constants of the matrix. So basically a matrix will be like this: 2, 4, 4, 3. Just put a bar here to represent these constants, 6 and 7. So this is your augmented matrix. Now step 2, what you have to do is, now you have to do lot of row operations. Why I need to perform row operations? Perform row operations to transform the matrix. We need to transform the matrix to row-echelon form. Now what is a row-echelon form? It's nothing but the upper. You need to transform it to a upper triangular matrix first. Okay, so how do you do it? Just write this equation. This symbol means that it is reduced to. So I'm going to reduce this matrix to. So for the goal is what? I need to have a row-echelon form. Row-echelon form means this diagonal matrix should become 1. Okay, and since in this case we are trying to reduce it to reduced echelon form, let's transform the matrix to reduced echelon form. That means what? I am going to have diagonal matrix as diagonal values as 1 and the rest of them as 0. So that means only this is going to be 1, this I am going to make it 0. So how do you make it? First let's focus on making this first element as 1. This is nothing but the first element in your matrix. So how do you make it as 1? Just divide this row by 2, right? So first row is R1. I am going to divide it by 2. So if I divide the first row by 2, what happens? 2 by 2 is 1. 4 by 2 is 2. Then 6 by 2 is 3. The second row remains as it is: 4, 3 and 7. Now what should I do is, now this work is done. Now we will focus on making the other values as 0. Okay, so let's focus on making this as 0. So how can you make that as 0? 4 minus 4 times of 1 will give me 0. So that is nothing but R2 minus 4 times of, this is nothing but R1, right? So what I'm going to do is R2 is equal to R2 minus 4R1. Keep the first row as it is. Now you reduce the second row. Second row is, what is the second row value? 4 minus 4 times of 1 is 0. 3 minus 4 times of 2, right? 3 minus 4 times of 2, that would be 3 minus 8, that is minus 5. Next 7 minus 4 times of 3, so that is 7 minus 12, that is minus 5. Okay, now this is done, this is done. Now let's focus on making this as 1, right? We'll make this as 1. So how can you make this as 1? Just divide it by minus 5. So what with the transformation equation? R2 will be equal to R2 divided by minus 5. So first row remains as it is. Divide the second row by minus 5. 0 by minus 5 is 0. Minus 5 by minus 5 is 1. Minus 5 by minus 5 is 1. Now this is done, this is done, this is done. Now what is rest remaining? This one. So this I have to make it as 0. So how will you make it as 0? 2 minus 2 times of 1, right? That will make it as 0. So R1 is equal to R1 minus 2 times of R2, right? So now I am just transforming first row. So 1 minus 2 times of 0 is 1. It remains unchanged. 2 minus 2 times of 1 is 0. 3 minus 2 times of 1. 3 minus 2 times of 1 is 1. Second row remains as it is. So now you can see that we have achieved the reduced echelon form. So this is the reduced echelon form. And it can be observed that x1 is equal to 1 and x2 is equal to 1. This is the solution. Okay, so this is a way that you can solve your Gaussian elimination matrix using the Gaussian elimination method. Thank you so much.